Okay, part two. So we're on number 17 now, and they want us to write an example below as two equivalent expressions, one involving addition and the other involving subtraction. And they give us an example, but basically they want us to write a subtraction expression that would give us a difference of 4, and then an addition expression that would give us a sum of 4. So I'm going to start with subtraction, and there are multiple answers here. So to get a difference of 4, I could do 8 minus 4, I could do 10 minus 6, I could do 7 minus 3, I could do 20 minus 16. I think you get the idea. I'm going to do 8 minus 4 because that would give us a difference of 4. So that's my subtraction expression. And now I need an addition expression. So I'm just going to rewrite it like we practiced at the end of the first video. So I'm going to leave my 8 the same, and I'm going to change this to plus a negative 4. And my 4 negatives would take away 4 of those positives, forming 0 pairs, and I'd have 4 positives remaining. So those are my examples for number 17. For number 18, if the answer is negative 2, then I need to have a smaller number minus a bigger number. So for example, I could do 2 minus 4. I could do 6 minus 8. I could do 8 minus 10. So lots of examples that would all result in a negative 2. I'm going to do 6 minus 8. And so if I'm at 6 on a number line and I subtract 8, it will definitely put me below 0 at negative 2. So that's my subtraction expression, and I'm going to rewrite this as addition for my addition expression. So 6 stays the same, and I'm changing this to plus a negative 8. 6 positives will take 6 negatives. Of course, it'll leave us with 2 negatives for our sum. Number 19, kind of like number 18, I need to subtract a larger number from a smaller one and able to get a difference that is negative. So to get a negative 4, I could do 6 minus 10. I could do 2 minus 6. And if I rewrite that as addition, I'm looking at 2 plus negative 6. So that's all they want us to do for those three. And remember, answers could vary. There's more than one way to answer these. So I originally thought we'd skip 20, 21, and 22, but we'll give these a try. These aren't as straightforward for students. These are a little bit harder, but we'll get through these. So they want us to write two subtraction expressions, two different ones that will result in each of these answers given. So for number 20, if I want a difference of negative 2, I could do something like 4 minus 6. I could have done 2 minus 4. Like we did for number 18, we could do 6 minus 8. Okay, but I went with 4 minus 6. So again, more than one answer. Okay, now I'm looking at their example here. So they did 3 minus 7, whereas I did 4 minus 6. And then I noticed that they just changed the order. So their negative 7 is going to come first. So I'm going to have a negative 6, and then I'm going to subtract. I would need to subtract 4 negatives. So if you think about the subtraction chip model, if I start with 6 negatives and then remove 4 negatives, I will be left with 2 negatives. So for number 21, let's see, I could do 4 minus 8. I could do 3 minus 7 like they did in their example. Maybe better not to use the one they did. So maybe we'll do 4 minus 8. So 4 minus 8 would definitely give us a negative 4. And now if I start with a negative 8, think about the chip model, so 8 negative chips, I would want to take away 4 negative chips, and that would leave me with 4 negative chips remaining. For number 22, let's see, I could do 5 minus 6, I could do 4 minus 5, I could do 2 minus 3, I think I'll do 5 minus 6. So 5 minus 6 would result in a negative 1. I could also start with a -6, and again, think about the chip model. I would want to take away 5 negative chips. And if I take away 5 negative chips, I'm left with 1 negative chip. So these subtraction expressions that we wrote for each of these 3 problems, both will result in the answer that we were looking for. Okay, number 23, we've answered this question before. How will you determine if that symbol there is telling us to subtract or if it's a negative sign in front of a numeric expression? So remember that when we answered this question in a previous lesson, we said if you circle the operation, then you will know if it's subtraction or if it's telling you that the following number is negative. So I'm just going to write down a circle the operation, and you will know. All right, on to the last page, and on the last page we have a couple of word problems. And let's see what they want us to do. So we do have to draw a model. They give us our choice. It can be a chip model or a number line model. They want us to write an expression, so we have to write out either an addition expression or a subtraction expression. They don't say which one, so it'll depend on the problem. And then we write our answer in context with a complete sentence. So these problems are not new to us. Lewis picks up a football that has been fumbled by his quarterback 12 yards behind the line of scrimmage. So 12 yards behind, I would use a -12 to represent that. He runs 15 yards before he is tackled. So if he's going to run forward 15 yards, I'm going to add 15. And they want to know where is he relative to the line of scrimmage. So he was 12 yards behind to start, and he's run 15 yards. So we can probably all figure out where he's going to be, and we know what the answer is, but they did ask us for a model. So coming up, I'm going to draw 12 negative chips. So I've got 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I better count those to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 shaded chips for my -12. And then of course the 15 is going to be more chips, but they're not shaded, so they're a little bit quicker to get on the paper. So that should be 12, 13, 14, and 15, but I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, we can see that definitely there would be 12 zero pairs. I'm looking at 3 unshaded chips at the end there, so +3. And remember the question asked, where is he relative to the line of scrimmage? So a +3 is telling me that he's in front of instead of behind the line of scrimmage. So we'll say Lewis is 3 yards in front of the line of scrimmage. And if you're like me, I have no idea what that means, but I can still do the problem. Not a football fan. I know some of you are, so I'm sorry, but it's not my thing. Okay, number 25. Leah owes her friend $7. So owes her friend $7. I'm going to use a -7. Her friend forgives $3 of the debt. So when her friend forgives $3, I could do one of two things. I could add a +3 because $3 is forgiven, or starting with that $7 that Leah owes, we could subtract 3 of the dollars that she owes. So I could write either addition or subtraction for this one. It just depends on which one makes the most sense to you, but either one of them could be used to find the answer. And I'm going to go ahead and model both of these. So I'm going to use a chip model again. A number line model would have been fine for number 24. and number 25. But if the number line isn't provided, I tend to do the chip model unless the numbers are really large. Then I would maybe draw the number line. Okay, but in this case, for number 25, I'm going to start with 7 negative chips. That's how much Leah owes. So 7 negatives to represent that, and then I'm going to add positive 3 to represent the $3 that her friend is going to forgive of the debt, and that's going to leave us with 4 negative chips, so negative 4, telling us that Leah still owes $4. If I model the subtraction expression, I'm still starting with 7 negative chips, but this time I'm taking away 3 negatives. So I'm just going to remove 3 of those negative chips, and notice that I still have 4 negatives remaining. So Leah owes $4 still, regardless of how we write the expression or show the model. So in context, we'll say Leah now owes her friend $4. And no need for a negative sign on our answer because we've used the word owes, and that takes care of it. So now you have the rest of the period to work on your 2.1e homework assignment. Make sure you use these notes and read directions when you're completing that assignment. There is also a worksheet for homework that the substitute should pass out, and that worksheet is a good little review of adding and subtracting with chip models, with number line models, and with no models at all, which is what our quiz next week will cover. So we want to make sure we complete that review. And when I'm back on Friday, we'll go over both 2.1e homework and that review worksheet, and I can get all your questions answered. Your job is to make sure you've tried every problem and used your notes, done the best you can. With that said, I will be here today after school, so if you have questions, come on back or stick around if you're in period 6. I will also be here Thursday morning if you have questions, and Thursday after school, and Friday morning, and Friday after school. So lots of times to see me if you're confused on any of this stuff in the first section of Module 2, leading into our quiz, which is next Monday, October 16th. So time to work on homework. Please use the rest of the time you have productively and be good for our substitute. Pretty, please.